So I'm Alex, and I'm working for Rain as a R&D scientist. I have a background in molecular biotechnology and plant pathology, and I'm working mainly on the Rain Vision System, the camera, and the analytics. The Rain Vision System camera is a multispectral camera. It has 9 different wavelength bands, starting from 475 nanometers up to 940 nanometers. You can control each of those different wavelength bands individually, but in general, we measure them sequentially and assemble a multispectral image from it, which you can use then for your downstream analyses. The Rain Vision System camera is special in a way that it has active lighting. This has a lot of advantages because we know the light we are putting on the surface of the plants and therefore can calibrate for it. But it also has some advantages because it requires a low light or ambient light environment, and we actually recommend measuring in the darkness. But on the other hand, it's possible to do a calibration inside the camera and get reflectance value without the need to measure white reflectance each time. You can also do a preview mode, which is quite nice for setting up the camera. You have a slow video stream, which helps you positioning your camera system. You are also able to control the scheduler. We have different scheduler modes. You can image at certain times of the day, but you can also set up a time period. Let's say you want to image every hour. You can set this up in there. If you're using it in an integrated system, like for example with the Rain growing system equipment, you can also set it up to output signals, either digital signals via wireless communication, or also signal output via its outputs. You have a 20-volt input and also output signal, which can either control the camera, so you can have an input that then triggers imaging from the camera, but you can also have an output that, for example, signals to the control system that it should switch off the lights in case you want to image in a grow facility where the lights are controlled like that. So I'm a scientist myself, so it's important to me that we are transparent what we do inside the system and how we calculate our values. And you can access all the presets and all the values we input there through the camera interface. And that, as I said, it's important for me to share the information, so it's not just a black box for you, but you know what happens with the measurements, with the readings of the values, so they are turned into reflection values. It's also fully, let's say, customizable in a sense that you can control each spectrum and basically also create your own multispectral group with sequential imaging of the same wavelength bands. It's very flexible in a sense if it needs to be, but it can also be a very simple and straightforward tool to use with, for example, the presets we provide to you. So it's the best of two worlds, in my opinion. It can be a tool that can be used easily and fast with the setup we provide you, but it can be also adjusted to like very specific experimental needs, and it's very powerful. So the camera has a wireless connection. You can connect it to your networks, your wireless network, but you can always also use it in access point mode, so it does not need a network connection. If your institution network, your university network has special security measures, we need to talk to your IT security if we can make it work. But you can always use it as a access point as well. So you can control it wirelessly with your end device and set it up. And also the camera does not need any internet connection while it's operating. So the full distance from the plant surface to the camera is from 30 centimeters up to 1 meter 50. We recommend as the best distances 60 centimeter to 1 meter. We have presets for 30 centimeter, 40 centimeter, 60 centimeter, 80 centimeter, 1 meter, and 1 meter 50. So if you use these presets, you don't have to do the calibration on your own. You can just simply use the camera. The camera itself can't directly measure plant water stress. but it will give you means to investigate water stress. The camera itself outputs multispectral images, so it images at the different wavelength bands, and you will receive it as an output, and it's up to you to analyze it and make sense out of it. We also provide an analytics suite to analyze your multispectral images. In fact, it actually can also work with hyperspectral images from cameras from others. But it neatly connects to the Rain Vision System camera, and you can use it also to download images and analyze them online. Right? We published it as an open source piece of software. It is fully based on PlantCV. PlantCV is a open source Python library for plant phenotyping developed by a nice group of people from the Danforth Center. And it can be used to analyze your images, for example, for things like water stress or other parameters you're interested in. So if you are interested in measures like the water stress, you usually use indices. This is basically putting different wavelength bands into a relation, which have been developed or described in the scientific literature. And what you would do is you would look for an index that reflects the measure you're actually interested in, and will perform an analysis and apply this index on your image. And then you need to decide, or you put a threshold and compare the numbers to see like if there are changes. You could have like relative values from the beginning to the end of your experiment and see if there are any changes. But in some cases, it's also possible to compare different experiments with each other. Rain Vision System Analytics is free of any cost. It's actually open source, and you can download it for free from the Rain Vision System webpage. And it's also available on GitHub, so the raw code. And we welcome everybody to leave us comments, suggestions there, and maybe also we're looking for contributors that contribute their code, their ideas to our software. The Rain Vision System can integrate well with other devices. For example, if you take an example setup with the whole Rain growing system gear, you could have a setup in which, for example, the camera takes images of your basil plants, and you have a basil variant which has a high anthocyanin level, and you want to control this anthocyanin level to some extent. So you would set up the camera to image those basil plants. The camera then can be connected to the analytics application, which then online can analyze the images for example, the anthocyanin reflectance index. And this gives you some idea about the relative anthocyanin concentration, and you want to keep it either like your experiment before or to some certain level. And if you want to increase it or decrease it, there are ways. It's influenced by the light quality. So you increase one or the other color, and then the anthocyanin levels can be like influenced. Right. And so the analytics can also output and send values via MQTT, the network protocol, and then, for example, send this to control software, in our case, Circadia, which then in turn can control the light spectrum and thereby influence the different light levels as well as light quality. Right, that would be an example for a closed loop where the camera basically via a pipeline influences the light, which then in the end influences properties of the plant. So the camera can't tell you which nutrient your plants are deficient in, but it can give you The camera itself can't give you also an idea, but what you can do is you can analyze the multispectral images, and depending on your analysis pipeline, you will get an idea how well your plant does. And if you know your system very well and you know also other parameters, for example, you know what kind of fertigation system you have and what you are adding as nutrients, then you will get an idea of potentially like what's missing, but it needs more than just the information you get from the multispectral image. The Rain Vision System camera can't detect plants. It gives you a multispectral image, and it depends on your downstream analysis if it's possible to detect a single plant. There are nowadays very powerful algorithms and AI models that can actually detect single plants even if the canopy is closed. But as I said, it requires artificial intelligence. For everything else, there are other strategies that will help you to analyze a full canopy of plants. So the IP rating of the camera is 42 if the camera is facing downwards from the surface, and it's 40 if the camera is facing sidewards or upwards. So the field of view of the camera at 1 meter distance to the surface is 120 centimeters times 80 centimeters. So if you want to learn more about the Rain Vision System camera or need additional information, please get in contact with our sales personnel.